Okay, so this is going to be kind of a hard one for me to completely work out without a calculator screen. And since I'm not at school, it'll be hard. But think about moving everything to one side. So if I move the negative 18 over, it becomes positive 18 is less than or equal to 0. And so if you think about this over here, what's on the left, this is the standard form of a quadratic. So it's a parabola. And so if you think about it like that, what I'm really saying is, where is the parabola less than or equal to 0? And it's going to be on some interval. So again, if you think about graphing this parabola, we know a few things about it. We know it's going to open up because the leading coefficient is positive. And so if I'm looking for the parabola is less than or equal to 0, I'm looking for where it's below the x-axis. That's really the kind of problems that you have here. So a couple of ways you could solve it. The way that they teach at Northeast is just put this in your graphing calculator, and then you're just finding the x-intercepts. Right? If I know this x-intercept and this x-intercept, then the parabola is less than 0. It's beneath the x-axis between these two x-intercepts. So again, I'm just making this up right here. Let's say this was negative 2 and 2. Then the answer would be from negative 2 to 2. And those would be included because it could be equal to 0 there. But that's the way that, again, if you took it at Northeast, they would teach you put in the graphing calculator. Another way you could do it, you could solve for the x-intercepts by either using the quadratic formula or by factoring. So I'm going to factor this. There's a GCF of 2. So it leaves me with z squared plus 6z plus 9. And so then this says, oh wow, this is going to be an interesting one. So then this would factor to be z plus 3 times z plus 3. And so if you think about it, where are the x-intercepts? Well, there's an x-intercept at negative 3, and it happens twice because it bounces off at negative 3 then as a multiplicity of 2. And so the only place that the graph is less than or equal to 0 is at negative 3. And so I would have to look at, if it looks like it has to be an interval notation, it would be from negative 3 to negative 3. That'd be a weird answer for that. But I think that's what they'd be looking for. But in general, the way that you would solve these problems, get everything to one side, and then it'll either say it's less than or equal to 0, greater than 0, something like that. So if it's greater than 0, you're looking for where's the graph above the x-axis. If it's less than 0, you're looking for it's below the x-axis.